As we described before, the problem of the firm that is going to give us the supply function is maximized over Q greater or equal than 0, P times Q minus C times Q. Remember that this is revenue, and you can think of this as the benefit of producing, and these are the total costs. We're going to denote the solution by Q star of P. This is called the supply function of the firm, how much it wants to produce at any price P. Let me make a couple of remarks. Remark number one is I'm simplifying the notation quite a bit here to make things less overwhelming. Otherwise, this just becomes a collage of symbols and a little bit impenetrable. But I want to highlight that remember always that C of Q, the total cost function, is a function of the input prices, as we have seen before. And the same thing is true for Q. Strictly speaking, I should have written Q of P given the input prices. I'm going to drop this part, and I'm going to drop the input prices from the cost function to simplify the notation. But don't forget this. The second thing is that it's still going to be the case that all of the insights that we developed in Unit 1 about how the solution for this is going to have to trade marginal benefits and marginal costs are going to hold. But things are a little bit more subtle in the case of the firm, and because of that, we need to look at different cases at a time to really understand how this works. To start developing some intuition about how this works, let's look first at a relatively simple case, which is when we have pure decreasing returns to scale. By pure means I mean there are no fixed costs or semi-fixed costs. So that's a case in which the cost function basically looks something like this. It's exploding up. So like this. These are the total costs. And remember that for this case, we had that the marginal cost curve may look something like this, maybe linear, maybe increasing, and the average variable cost equals to the average total cost curve. It also has a shape like that and is below. Now, for this particular case, notice that the marginal cost is greater than 0, and the second derivative of the marginal cost is also greater than 0, and this implies that the concavity conditions of the optimization problems that we had studied in Unit 1 hold. That means that the solution, as a result, the solution is just given by the first order condition, marginal revenue, which remember in the case of the firm is the marginal benefit, equals to marginal cost, and the marginal revenue is just P. Every unit of Q gives us revenue of P. So what does that mean? That the solution is just given by, at any price, the quantity Q that makes the marginal cost equals P. So let's plot that. Let's plot what the solution looks like. I'm going to plot the marginal cost curve in this case. This is quantity. This is dollars per unit. And suppose, for example, that we had a price P, let's say at this. What would be the demand at that price? It will be the supply, it will be exactly this. The quantity at which marginal cost is equal to price, so this will be Q star of P. It's easy to see by doing that at any price that the supply of the firm is just the marginal cost curve in this case. This is Q star of P. Importantly, this is as before when we have price in this axis and we're looking at it this way. For every price, what's the quantity supplied? Notice that we have the marginal cost curve, even though these are the same locus of points, the marginal cost curve is a function of Q, and that's when we look at this curve from this perspective. This should be straightforward and familiar from all of the work we did for demand. It's just similar, but for the case of the supply curve. Now notice finally about this, just a little bit of intuition. It's very nice. The supply curve is increasing with prices. The higher the prices, the more the firm wants to supply. And the intuition is very simple. It's because the higher the price, the more unit it can produce at a marginal cost lower than that. Now let's look at the case in which we have decreasing returns to scale and semi-fixed costs. That's a case that looks like this. This height is the size of the semi-fixed cost. This is Q. I'm going to draw very quickly what the other curves look like. Like from before, we may have a marginal curve like this, an average variable cost curve like this, and the average total cost curve like this, that asymptotically gets closer and closer to the average total curve. Now, what is interesting about this case as compared to the previous one is that the introduction of the semi-fixed costs make interesting the issue of the shutdown condition. So we're going to solve the problem in 2 steps to investigate this. Step 1 is, when does the firm shut down? I.e. sets Q star of P equals to 0. Now, if you stop to think for a few minutes, you'll see that the answer to that is actually fairly easy. And to do that, let me call this height the minimum of the average total cost curve, and this point, the point at which the minimum takes place, the quantity at which the minimum takes place. Okay? Now notice the following. Suppose that you have a price below there. So you have, let's say, a price over there. At that price, the firm necessarily loses money, because it doesn't matter which quantity it chooses, the average total cost per unit is always above the price per unit. So there are losses. That implies that if P is less than the minimum of the average total cost, then Q star of P has to be 0. So what do we learn from that? We learn that the supply function has to be there for prices below. Now, let's ask what happens at P above the shutdown condition. Say greater or equal. Well, notice the following. Let's take a potential price. Let's say I'm going to do it in gray. Let's say this one. Notice that at that price above the minimum ATC, there is a whole range of quantities that the consumer could take at which the price per unit is above the average total cost curve. So profits are possible, so the firm is going to want to be in the interior. But we also know from all of the logic that we have developed before that if the firm is in the interior, the solution is going to be given by marginal revenue equals marginal cost, and this is equal to P. In other words, the firm is going to choose the quantity at which marginal cost of that quantity equals to price. But that implies that the firm has to be there. Now, what happens when the price is exactly the minimum ATC? Well, the firm is indifferent between choosing that point and that point, both of which give it a profit of 0. And in red, I have done what is the supply of this firm. Now let's look at the case in which there are semi-fixed costs and actual fixed costs. So that's going to be a case that looks like this. The total cost function still explodes like this. But now we can think that there are semi-fixed costs and fixed costs. And remember the difference. Semi-fixed costs get paid only if quantity becomes positive. Fixed costs get paid even if the quantity is 0. To deal with this case, it's going to be useful to define the following things, which I'm going to call the average total cost, but only taking into account the semi-fixed cost, which is equal to the average variable cost plus the semi-fixed cost divided by Q. And then the average total cost, taking into account both kinds of costs, so I'm going to see SFC plus FC, and this is equal to the average variable cost plus SFC plus FC divided by Q. You will see in a second why this is so useful. Now, let's draw here the other cost curves. So we may have something like, let's say, the marginal cost curve, the average variable cost curve. And now the key here is that I want to draw separately both types of average total cost curves. I'm going to do this one in red, and that's going to be a curve that looks kind of like this. That's going to be the average total cost curve that only takes into account the semi-fixed costs. And I'm going to do in green this one, which is going to be something that looks like this. It crosses at the minimum, average total cost curve of SFC plus fixed cost. And as before, let me define points here, which is the minimum of the average total cost curve only taking into account the semi-fixed cost, and this is the quantity associated with that. Now, the key way to see the difference between this problem and the previous one, in which there were no fixed costs, is to look at the problem of the firm. The problem of the firm now is to maximize over a quantity greater or equal than 0 revenue minus all of the costs that I'm going to spell out for you, which are fixed costs, plus semi-fixed cost, provided that Q is greater than 0, plus this variable cost of Q. Now, notice that the solution of this problem does not depend on the fixed cost, because there are an absolute constant with respect to Q, so we can take that out. And what we get is that the optimal solution with this supply is identical to the solution of the problem when there are no fixed costs. So what do we get? We are going to get exactly the same solution as before, which is given by the case in which we ignore the fixed cost, which is given by this average total cost curve. So the supply is going to be given by this, and then the part of the marginal cost curve that is above it. Okay, so this is going to be Q star of P for this case. Now notice a couple of things. First, and very importantly, the fixed costs do not matter for what the optimal solution is, but they matter enormously for profits. You could imagine bringing the fixed cost up to infinity, not changing what the firm does, and yet it would lose an arbitrarily large amount of money. In other words, the fact that the fixed costs do not affect the behavior of the firm does not mean that they don't affect profits. The second remark that I want to make is to again highlight that there are these two types of kind of threshold or fixed cost. One is the semi-fixed cost, the other one are the fixed costs, and that the curve that determines where the supply becomes positive and at what quantity is only the one that depends on the semi-fixed cost, because those are the only ones that are affected by behavior. The fixed costs are just fixed costs, and therefore should not affect choices when the firms are behaving optimally. Now let's look at another canonical and very interesting case, which is constant returns to scale. So suppose your cost function looks like this. Just starts from the origin and is some mu of Q. That's your total cost. We've seen before that in this case, you have your marginal cost equals to your average total cost equals to your average variable cost equals to mu. I hope that it's very easy to see for you what the supply function is in this case. And it actually depends on what the price is relative to mu, whether it's less than mu, equal to mu, or greater than mu. So suppose, let's look at each case. Suppose that the price is greater than mu, so you are in this region. In that particular case, the price is greater than the marginal cost of production, and every time you produce a unit, you make a profit equals to P minus mu. So how much do you want to produce? Infinity. You want to produce infinity, because in that case, you will make infinite profits. What if you're in this case below? Well, in that case, the price is less than the marginal cost. Every time you produce a unit, you lose money, so you want to produce 0. In that case, you want to be there. Now, what about when price is exactly equal to mu? Then you are indifferent between producing and not producing each unit because you're making no money. So here you're willing to produce anything. You are indifferent. You make 0 profits, but it doesn't really matter. So basically, the supply function looks like this. This very weird looking thing in which at the price equals to the marginal cost, it goes to the right all the way to infinity. Finally, consider the case of semi-decreasing returns to scale that we have seen before with no type of fixed cost whatsoever. So in that case, the cost function just looks something like this. First it bends like this, then it bends up. And as we have seen, that's a case in which the marginal cost curve is U-shaped, looks something like this, let's say, and the average total cost curve is equal to the average variable cost curve and looks like this. And let me, as before, call this the quantity at which we have the minimum of the average total cost curve, and here the minimum of the average total cost curve. Now, what is Q star of P in this case? Not surprisingly, by now you're going to have that it depends whether the price is below that minimum ATC or above. If it's below, for exactly the same reasons as before, since there is no possible to make money, the firm shuts down and supply is there. So in that case, we get a zero supply. Now, what is interesting in this case, and it requires some thought, is what happens when the price is above, let's say at a price like that. Well, clearly, there is a whole range of points at which profits can be made, all of this, since the price is above the average total cost curve. That suggests that we're going to want to be in an interior solution. Now, it's important that you have to be careful here just to say that price equals marginal cost, because there are 2 points here and here at which the price and the marginal cost are the same. But notice, however, that at this point, the average total cost curve exceeds the price, so only losses can be made. Therefore, the only point that satisfies the first order condition and at which positive profits can be made is this one, which means that the supply looks like this. And again, here, the firm is indifferent. So this is Q star of P. So how do we write this? We're going to say that as Q, such that 2 things are true. First, price is equal to marginal cost of Q. And second, price is greater or equal than the average total cost at Q. Only those points satisfy that property. Please do not become overwhelmed by the number of cases that we have covered. I wanted to develop them in detail so you have a deep understanding, but you don't have to memorize them. All I want you to see, either by looking at your notes or going back through the videos, is that this is exactly like the logic that we developed in the previous unit. Conditional or being in a positive level of production, you're going to want to set marginal revenue, which is a marginal benefit for the case of the firm, equals marginal cost. So that has not changed. The only addition that has happened that you can see throughout the cases is that we need to worry about a shutdown condition. Cases in which the firm may not want to produce at all, that come often from this existence of these semi-fixed costs. So the logic is very similar as before. Find the optimal solution by equating marginal benefit and marginal cost, but do an extra bit of thinking to take into account the possibility of shutting down production in the firms.